Lesson 10.1, Graphing Square Root Functions.
So when we have a square root function, you can see the graph right here. Kind of looks like a half of a parabola, maybe. A lot of times they're sideways on the graph. We have a function that contains a square root. The independent variable is in the radicand. It's literally under the square root symbol or the radical symbol. We have the parent function, which is the square root of x. The domain of f is x is greater than or equal to 0, and the range is y is greater than or equal to 0. So because we start at 0, 0 right here, and it increases on the entire domain, so the minimum value of f is 0. That's kind of one of the ways that we can see the range. All right, so the value of the radicand in the square root function cannot be negative. The domain of a square root function includes x values for which the radicand is greater than or equal to 0. So we're going to have to solve for this x minus 5 being greater than or equal to 0, and solve for x to determine what the domain of our function is going to be. So for this one, we want to say, okay, we have this negative x. I want it to be greater than or equal to 0. When I divide it by a negative, and I'm working with inequalities, I will reverse the symbol. So that means x can be less than or equal to 0. And that makes sense because right now we have a negative x. So if we try to put in some positive values like 1, 2, 3, or 4, we'd have a negative number under the radical. We don't want that. But if you put in negative values, the opposite of a negative value is a positive value. So that's how we can solve for that one. So go ahead and do number 2 right here. Go ahead and work this out and let me know what you think the domain of the function is. Okay, I'm going to go ahead and work it out. So we'll have x minus 3 to be greater than or equal to 0. So we'll add 3 to both sides. This does not reverse the symbol. So we have x can be greater than or equal to 3. Okay, go ahead and circle that for you. So 3 minus 3 is 0. And then we can be greater than 4, 4, 5, 6. But if it becomes like 2, then we would have that negative underneath there. In number 3, we want 1/3 of x to be greater than or equal to 0. So we'll multiply both sides by 3, and we get x is greater than or equal to 0. So to graph them, we'll describe the range after we're done graphing. So we go ahead and use the domain, right? So we know if we have the square root of x, we want greater than or equal to 0. Pick some values, 4 or 5, usually good. Substitute those in, solve for f of x or y, plot the ordered pairs, draw your smooth curve starting at your starting point. And then to describe the range, go to that starting point, and then y would be greater than or equal to 3 in this case. So again, we have 3x greater than or equal to 0. Divide by 3, x will be greater than or equal to 0. So if I make my x, y chart here, and I want it to be greater than or equal to 0, so I can start at 0, do 1, 2, 3, 4, so I have about 5 points. So 3 times 0, and the square root of that would be 0. 3 times 1, so the square root of 3, let's figure that out, is 1.7. 2 times 3 is 6. Take the square root of that, 2.4 for your output value. Make sure that you're getting some of these to work out too. So if our input value is 3, 3 times 3 is 9. Square root of 9 is 3. That's a perfect square. Square root of 12, because we have 4 times 3, is about 3.5. And then we'll make our axis here. Okay, so then we'll graph them. Here's our 0, 0, 1, and 1.7, 2, and 2.4, 3, and 3, 4, and 3.5, and it starts to curve there. And then when we draw this, okay, like this, we'll describe our range as y is greater than or equal to 0, because it's going to increase greater than there. All right. Number 5. Why don't you go ahead and work out number 5. Let's start by determining our domain. So we have this negative x has to be greater than or equal to 0. So if we're dividing by a -1, that means that x has to be less than or equal to 0. So let's pick some values that are less than or equal to 0 and graph number 5. All right, so I got a graph. I have a 0, 0. I have -1, 2. I have -2, 2.8, almost 3. I have -3, 3.5, and -4 and 4. So if I were to draw it, okay, and then my y would be greater than or equal to 0 for my range. All right, for number 6. In number 6, we have x plus 3 to be greater than or equal to 0. So we want x greater than or equal to a -3. So we make our xy table. We can start with -3, -2, -1, 0, 1. So we would substitute this in. So -3 plus 3 is going to be 0. The square root of 0 is 0, and then -1. So -3, -1. Okay? When we have -2, -2 plus 3 is a +1. Square root of 1 is 1. 1 minus 1 is 0. -1, this gives us the square root of 2. And if I calculate that, that's about 1.4. And then we'll subtract 1, and we get a decimal value of this 0.41 something. Okay, so 0 plus 3, now we're taking the square root of 3, and then we're going to subtract 1, so we'll get about a 0.7. 1 plus 3 is 4, so we should get 1, 1. All right, so I'm going to kind of come over here. All right, so -3, -1, so 1, 2, 3, -1 is right here. -2, 0, -1, about right where my messy axis is. It appears that I wrote part of the number. I don't know what I said in the video. I didn't mean to. So we were taking the square root of, so we had 0 plus 3, the square root of 3, and then subtracting 1, so it's 0.7. I might have said 0.7 and 0.1. I don't know, but this makes a little more sense if we're almost at 1, it's a little bit higher. And then we're at 1, 1. So we'll draw our graph kind of like this, right? Now, look at this range, right? It's starting right here at -1. So y would be greater than or equal to -1. All right.
Okay, for this word problem, we have the velocity y in meters per second of a tsunami can be modeled by this function. Y is equal to the square root of 9.8x, where x is the water depth in meters. It says using a graphing calculator to graph the function, at what depth does the velocity of the tsunami exceed 150 meters per second? All right, since we do not have a graphing calculator, I've taken the liberty of using Desmos. So I'm going to show you what this looks like if we use a Desmos calculator right here. So we put in the function, and this is what it looks like. Okay. Now, when we're talking about, at what depth does the velocity exceed 150, right? That means that, y is going to be what? Greater than or equal to 150. So we're talking about the range there. So we're talking, over here, and then where would it intersect or meet up with our graph, and what value for x would we expect, for the water depth in meters. So let's take a look at what it looks like. I went ahead, and the only way to really show you this was to go ahead and, kind of add a system. And so I added a horizontal line of y is equal to 150 so you could see where that would intersect. So here's our y is equal to 150 is the red line. This is our original function. And the place where they, intersect right there, and you can see that because the output is 150, the input is so close to about 2,300 meters that's what we would probably say. That at what depth we'd probably say, approximately, oops, I do not know what just happened. Okay, let's correct this. 2,300 meters. All right, so at approximately 2,300 meters, we can see that happening. So you'll be using graphing calculators a lot more next year. We just do not have that technology here at the middle school. And so, but sometimes it's good to see the application. Okay, and let's go ahead and see the next slide, which is the vocabulary and concept check. So you know what to do. Complete sentences. You are mathematicians communicating mathematically. Let me know which one you're going to be responding to, and then do so. And I will, if you have any questions, let me know, and I will see you in class tomorrow. So have a great night.